Okay, welcome back to WSHS Algebra 1 Virtual Tutor. Today's lesson is going to be on adding and subtracting polynomials. Okay, so a polynomial is when we have more than one term. So a polynomial is a monomial, or the sum and difference of monomials. So what is a monomial? With a polynomial, we have three different types. We have a monomial, a binomial, or a trinomial, and anything over a trinomial will just be known as a polynomial. So a monomial, with the root word mono means one. So a monomial is only one term. So for example, we have 2x. There is one term here. A binomial is the next type that we see a lot. And with binomial, the root word bi means two. So a binomial is two terms. So for example, we have 2x plus 3. Now this is two terms because the 2x and the 3 are separated by an addition sign. Same thing if we had a subtraction sign here, this would still be considered a binomial because we have two terms here. And then the last one is a trinomial. A trinomial has the root word tri, which means three. So we should have three terms in a trinomial. For example, we see this a lot for trinomials. X squared plus 2x minus 3 or something like that. Okay, where there's three terms because each term here, 1, 2, 3, separated by addition or subtraction. Okay, so all of these can be polynomials. We had 2x plus 3. We had x squared plus 2x minus 3. We could even have more than three terms. So if we had something like 3x to the 5th plus 4x to the 4th, and this continued to go on. Obviously, there's more than three terms here, right? So this would be known. We wouldn't call this 1, 2, 3, 4, 5. We wouldn't call this like a quintinomial or anything like that. We would just call this a polynomial altogether. Okay, so we have monomial for one term, binomial for two terms, trinomial for three terms, and then anything over that would just be considered a polynomial. Poly means more than one. All right, note, it is not a polynomial if there is a monomial, meaning one term, in the denominator. Okay, so if we had something like 2x squared plus 3x minus 4, and we saw this type of expression with a 2x on the bottom, there is a monomial here in my denominator, so this would not be considered a polynomial. Okay, so we're just going to answer these questions here. Is the following a polynomial or not? If yes, state the type of polynomial it is. If not, we would just put no. So if I'm looking at this one here, this is 2x plus 5y minus 6. So we've got one term, two terms, three terms. This is a polynomial, right? So yes. And the type of polynomial would be considered a trinomial because there's three terms there. Number 2, 11a squared bc cubed. How many terms are here? Well, this is just one term here, right? So yes, this is, and this is considered a monomial because there's only one term there. Number 3, we have 2 terms in the numerator, so it's a binomial, but we have a monomial, 1 term in the denominator. And we said that it's not a polynomial if there's a monomial in the denominator, so this would be no. Because of that monomial in the denominator. Okay, so that was just the basics of identifying and being able to recognize what is a monomial, what is a binomial, what is a trinomial, and knowing that these are all called polynomials. Because what we're doing today is we're actually going to add or subtract polynomials. Okay, so the main gist of this is when you add or subtract, what we're really doing is combining like terms. Okay, we are combining like terms. And for us to combine like terms, we have to have the same variable and the same exponent. Okay, so if I had something like this, 2x and 2x squared, I actually cannot combine these because even though they have the same variable, they don't have the same exponent. What would my exponent be if there's nothing written here? This is technically a 1, and 1 and 2 are not the same number, so we can't actually combine these. What we can do is if we had 2x squared plus 3x squared, now we've got the same variable, right, x and x, and we also have the same exponent. So these can actually get combined together. And when we combine them and add them, all we're really doing is adding the coefficients. 2 plus 3 is 5. And then this would just keep our x squared the same. So 2 plus 3 is 5, so that becomes 5x squared. Okay, so we're going to do these, but we're going to do them with more than just 2 terms here. We've got a lot going on, right? So as long as we can identify what like terms are, we should be able to easily combine these up. All right, so let's see what we've got here. We've got an example 1, 9y minus 7x plus 15a, and then plus negative 3y plus 8x minus 8a. So the way we do this, the steps over here. Step 1 is we're going to stack everything with the same variable, okay? I should say stack all of the like terms here, okay? Then we're going to combine like terms. So let's just add here, same variable and same exponent, just in case. So after we stacked, meaning line them up vertically, one on top of the other, we're going to combine like terms, so we're going to add them. Then we want to make sure we can simplify or write in descending order. I'll talk about that in a minute. Okay, so the first thing I see here is a 9y, right? So I'm going to write the 9y down. Do I have another y term that I can stack underneath this 9y that I can combine? And I do. I see this negative 3y. You always want to make sure you're taking the sign in front of that number. Okay, the next one I see here is a negative 7x. Do I have another term with an x in it? And I do. It's this positive 8x, right? And then last one here I see is a 15a. And that can be stacked with this negative 8a. So I grouped my like terms together, one right on top of the other. And I like to stack them so we can see we're going to add each one together, okay? So 9y plus, because when we combine, we're adding. 9y plus negative 3y, 9 plus negative 3 is 6. So this becomes 6y for that section. Negative 7x plus a positive 8x will give me a positive 1x. And then we have 15a plus negative 8a would give me a positive 7a. We want to make sure we're following along with our signs, right? So since I got all positive numbers, I should actually have plus signs between each of my terms. So my answer altogether would be 6y plus, now with this one, with the 1 being in front of the x here, I don't usually see that, right? 1 is typically invisible. We usually see it more like this. 6y plus x plus 7a. That would be my answer. All right, example 2, we're going to do the same thing here. What we want to do is group or stack our common variables, right? Same variable, same exponent. So the first thing I see here is a 3a squared. Do I have another term with an a squared in it? And I do not, right? Okay. Just going to write a line down there, because I'm separating it. I'm separating all of my terms here. All right, the next one I see is 3ab, positive 3ab. Do I see any other ab term here? I do. I've got this positive 5ab. So I'll put those together. Then I see a negative b squared. Well, if there is no number in front of my variable, I usually want to go ahead and put a 1 there just to make sure that I don't miss out on adding or subtracting that specific number. Okay, so this is really negative 1b squared. Do I have another term with a b to the second power? And I do. I've got it right here. So this is positive 4b squared. So what I'm going to do is I'm going to combine my like terms. When you combine, you're adding. Well, I have this 3a squared plus, what am I adding to the 3a squared? I didn't have any other term that was the same, right? No like term. So really 3a squared plus 0 is going to be 3a squared. Then I have 3ab plus 5ab. 3 plus 5 is 8, so this becomes 8ab. And these are positive numbers, so I want to put a plus sign between them. Lastly, I have negative 1b squared plus 4b squared. Well, negative 1 plus a positive 4 is going to give you a positive 3b squared. Again, I want to put my plus sign if it's a positive. If it was a negative number I ended up with, that just winds up being treated as a minus sign there, okay? So this would be my final answer. All right, example 4. Now we've got some subtraction going on here. Now I know this is subtraction, not addition, because if I look between my two parentheses here, I see a minus sign, right? So how did I know the other ones were addition? Same thing, between my two sets of parentheses, I saw the plus sign, right? So that's telling you whether you're going to add or subtract here. Now for the subtraction one, we've got to do a little maneuvering here first, because we don't want to keep it as subtraction. When we are combining like terms, typically we add them, right? So what we want to do whenever we see a subtraction sign between our polynomials is we want to change the subtraction to addition. So I can actually change subtraction, change the minus sign to a plus sign. But when I do that, I'm going to actually have to wind up switching the signs of all the terms on the right. So math is all about balancing, right? So what you do to one, you must do to the other. So what winds up happening is, because I'm changing this to a plus sign, I also have to change the signs of each of these numbers here on the right. So this positive 9m is actually going to be switched to a negative 9m. This negative 5n is getting switched to a positive 5n. And this positive 1 gets switched to a negative 1. Now the reason that we do that is because it kind of works out this way. If I had 3 minus negative 5, typically you might have learned this in the past. If you have minus, you do the keep change, or keep change switch you might have heard before. So we would keep the first term the way it is, change subtraction to addition, and change the negative to a positive. And that would give you an 8, right? So that kind of goes along with what we're doing here. This is just with variables and more than one term now, but the process is still the same. You would change subtraction to addition and then change the signs on the right. So here we have now a new polynomial over here. Okay, so I'm going to then keep following with the steps. Like we did last time, we're going to stack everything with the same variable and exponent. Okay. Combine like terms by adding, and then simplify. So we have 8n in my first set of parentheses. Do I have any other term that has an n in it? So if this is my 8n, I also have, if I look here, remember I changed this, right? So I kind of want to cross that out, so I don't want to confuse myself. So since I changed the signs because of that, the other n that I have is this positive 5n. Okay, then I see my 4m. If this is a 4m, the other term with an m in it is this negative 9m. So I want to stack those together. Then I see a minus 3 or a negative 3, so I got to keep that sign there, right? Do I see any other, and this is called a constant, do I see any other number that does not have a variable in it? And that would be this negative 1 or the minus 1. So I've got to keep those together. And now I can add, right? I'm combining like terms. So 8n plus 5n is going to be 13n. 4 plus negative 9 is going to be negative 5. So that's negative 5m. And then negative 3 plus negative 1 is negative 4. So my answer, I want to keep the signs the way they are. Okay, 13n minus 5m minus 4. That would be my answer. Okay, last one here. Again, if I look at my parentheses, between my parentheses, I see a subtraction sign. So this means I'm supposed to combine some like terms, but before I do that, I've got to switch my subtraction to addition, right? Changing the minus to a plus. And I'm going to rewrite my binomial here, this two-term, this polynomial, right? Two terms, binomial. So instead of this being a positive a squared, this will be a negative a squared. Instead of this being a positive 9b, this is now a negative 9b. So I want to cross this out so I don't confuse myself when I'm doing the rest of the math here. So let's start lining up the terms. I have 7a squared. Do I have any other term with an a to the second power that can go with this 7a squared? If I look here, I have a negative a squared. So we kind of talked about this before. If there's no number in front of the variable, we usually want to go ahead and put a 1 right in front of there, right? So this is really negative 1a squared. Then I have a negative or a minus 6b. Do I have any other term with a b? If I look here, I do. I have this negative 9b. Okay, combine like terms. So we're going to add. We've got 7 plus negative 1. 7 plus negative 1 is going to give me a positive 6. So this is 6a squared. And then negative 6 plus negative 9 is negative 15. So that's negative 15b. So if I'm putting my answer together, I get 6a squared minus 15b. So I want to keep that sign the way it is. Okay? All right, and that is how you add or subtract polynomials. Remember, if you see the subtraction sign, you've got to change the subtraction to addition, and then change all the signs on the right-hand side. And we know it's addition or subtraction because between our parentheses, we will see either a plus or a minus sign.